about your graphing calculator, these would be the basic steps for finding zeros, minimums, and maximums in the graphing calculator. That very first step is going to be important to all graphing things that we do. You're going to input your function into the y equals menu. So when I go up to the dot cam, I'll go ahead and show you what that looks like, where that y equals button is. In the y equals menu, that's where you type your function. There is a button that you'll look for on your calculator. If you're using a Texas Instrument calculator, that button looks like X, T, theta, N, and it's really just your variable button. So anytime you want the variable X, you can hit that button in the y equals menu, and that's going to bring it up in your function. Okay. Then I'll show you how to graph it. I'll show you some things about zoom. And you can look at the graph and you can decide, oh, there are some x-intercepts I could find, so those would be zeros, or there is a minimum, or there is a maximum. I'd like to find one of those. And in order to find any of those things, the next set that you'll do is second trace. So that's the actual keystroke that you make. Right above trace, I'll show it to you on the graphing calculator, it says calc. So it's just asking you, like, these are the things you could calculate in relation to the function. And there's a long list that shows up, and you would select whatever it is you decided you wanted to calculate. I wanted to find that x-intercept or 0, or I wanted to find that minimum. Okay. After you select what it is you want to find, your graphing calculator is going to ask a set of 3 questions. First, it's going to ask for left and right bounds, and basically what that's doing is it's saying, okay, you have this whole picture on your screen, now narrow it down, tell me what's close to left of that 0, and then tell me what's right of that 0, and kind of like narrow in on the 0. It gets a better answer if you're closer. And then the third question it asks is kind of a silly question. It says, like, basically, do you want me to guess it? Yes, that's why I came to this menu and pushed all these buttons. So then you have to hit enter one more time so it will guess it, and it'll give you an answer at the bottom of your screen. Okay. We're going to do this function right here, f of x equals negative x squared plus 13x minus 2. I'll go ahead and write it over here on the sideboard so that when I switch to my graphing calculator, you can see what it is we're typing. Okay, so we're going to switch to the graphing calculator now, and you can kind of see me run through these steps. Let me know if you have a question as I'm working on them. Okay, so on my graphing calculator, I want to find that y equals button, and all the buttons for graphing are right underneath the window. So even though it's hard to see those, my y equals button is going to be the furthest left. So I'm going to go ahead and hit y equals, and that brings up a menu. I'm going to clear out my menu so you can see me type those things in. Okay. One thing to note about TIs, and you've maybe experienced this in other classes, you have to be really careful with negative and minus. Those are 2 different things in Texas Instruments. So I'm going to move my calculator here. If I want to do negative x squared, I have to make sure to use this negative right next to the decimal as opposed to the minus or subtraction sign over in the operations. If I use the wrong one, it'll tell me I have a syntax error. So if you ever get syntax error in a calculator, check your negatives and your minuses. Okay, so I'm going to do negative x squared, so I'm going to hit that negative. That brings up a negative on my screen. And then remember the x, t, theta, n, it's right next to your colored alpha button. So I'm going to hit that to get x squared, and I'm just going to type in the rest of my function, plus 13x, and then minus 2. This time I made sure to get the minus sign over in the operations. And you can type all kinds of functions in there. You can do square roots. There's a way to get absolute values. Okay, so we can graph lots of things in here. And then the next thing I'd say to most people, if you want like the very basic window that is negative 10 to 10 in all directions, you can just hit zoom 6. Okay, some of you can just go right up here to graph, and it's already set to that. But you're going to see in mine, that's not really a good picture of the graph. Based on that function, we at least know it's a upside down parabola, or a parabola that opens down. So I'd like to see more of that parabola. So then here's where you kind of get used to just kind of playing around with your zooms. So I'm going to go to that middle button under my graphing window and select zoom. And if you need to see like a bigger picture, there's really two options that work. One of them, if I just push the up button so it goes up, the 10th one is called Zoom Fit. And what that does is it just fits the viewing screen to your actual graph. Okay. The other thing you can do is zoom out, Zoom 3, and I'm going to show you zoom out because this is what happens to a lot of people. They say, oh, I'm going to zoom out of that. So I go down to zoom out, I hit enter, and then I get the same picture I had before, and a lot of people are like, nothing happened. Okay. It's really, really hard to see, but right there at the origin, it's blinking. There's actually like a little cursor right there. And so you have to put that cursor where you want to zoom out of. And I do want to just zoom out of the origin. So I'm just going to leave it there and hit enter. Okay. So if you choose zoom out or zoom in, you're also going to at some point have to push enter so it actually zooms out or in. Okay. Just selecting that zoom won't make it zoom. So now I get this whole picture of a parabola, and what I see is I could find intercepts or zeros. I also have a maximum I could find, and that's where that keystroke from the notes that you maybe added into your notebook would be helpful. You're going to do second trace to get to that calculate menu. I can calculate values of my functions, zeros, minimums, maximums, intersection points, if there's multiple functions there. And then these are derivatives, integrals, things that you would use in calculus. Well, I'm going to find that maximum, so I'm going to choose 4. And I'm going to find the maximum. Notice at the bottom of my screen it's saying, what's left bound? Okay, so there's a blinking cursor. I think it looks kind of like a spider, even if it only has 4 legs. Okay, and I want to get that spider as close to my maximum as I can, but on the left side. Okay, so I'm thinking I'm still on the left side of that maximum. I'm going to go ahead and say this is the left bound. It's not a huge deal if you do it further left. You just don't want to be like the furthest away from it. Okay, it gets a more accurate read the closer you are. Now it's asking me right bound. So I'm going to use my right arrow and I'm going to say, oh, I'm not sure if I'm on the right side. Now I'm sure I'm on the right side of that maximum. So now I'm going to hit enter. And still nothing has happened. It says, do you want me to guess where the maximum is? Yes. So now I just hit enter. And my maximum, it looks like 6.5, 40.25. That's the same process I would use for zeros. Get on the left side of the zero, then move over to the right side of the zero, cross that x-axis, and then hit enter. I'm videoing this right now, so I post my videos online. So if you're, if you get a graphing calculator the weekend and you want to try it, you can go to the website and see that video. But that's really handy. Okay. Any questions about the graphing calculator? Yes.
And I can ask later, but mine isn't zooming out even if I press zoom out. It just continues to show up mine.
Okay, let me come right to you. I'm going to put up the slide for everybody to get started writing, and then I'm going to come look at it right now. Okay, so in your notebooks, we have 2 quick things we want to talk about. They won't take long, then we'll get started on our summer packet.
All right, so I go to y equals and I put in the correct equation. So when you go to the graph, it just shows the new.
Now zoom, choose out.
Yeah, so 3, right?
Yeah.
And it just.
Well, so there's a blinker. Yours is way over here.
Yeah.
You gotta you know how if you were on your phone and you went like this, it would zoom out of your face, not your friend's face over here.
Yeah, I know.
So I usually leave it at the center, but I mean, of course, if you're zooming in on something, you might go towards it.
Mm-hmm.
But I'm going to put yours back at the center and just enter, and it zooms out. So you have to hit enter before it actually zooms out.
Cool. Okay, thank you. Yep, that's here.
Okay, so average rate of change comes from section 1.5, and then the step function comes from section 1.6. Step function is going to help you with that pink sheet. Did I give you the pink sheet? Yes, okay. It's going to help you with the pink sheet for the greatest integer function. So if you were looking in your book and thought that was a strange function, we're going to talk about that one today. Now, Average rate of change is very similar to something that you have studied probably since freshman, possibly even middle school, and that would be the 3 words rate of change. A rate of change in Algebra 1 is a slope. Okay. An average rate of change is also a slope. The only difference here is it's a slope between 2 points in a non-linear function. Rate of change, slope, for linear functions is always the same. That's the definition of a linear function. You have a constant slope. We put the average rate of change here because we're talking about nonlinear functions. The slope is not constant any longer. That means I could give you a nonlinear graph, so I'm going to draw something that looks maybe like a polynomial. And I could find the slope between 2 points. It just won't follow the graph. So I'm going to select 2 points. And if I find the slope between those 2 points, I'm calculating the average rate of change. That line that I have drawn between those 2 points, it has a special name. It's called the secant line. So if you want to write that down, you can. It should sound familiar, one of your reciprocal trig ratios. And so the average rate of change is really just the slope of a secant line. A secant line is a line that passes through 2 points of a nonlinear function. Now, the formula for average rate of change is here. Please note this is the same formula for slope. If I give you a formula from slope from Algebra 2, Algebra 1, it'd be m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Same thing. But I've rewritten my y's so that they are in function notation. And so it's f of x sub 2 minus f of x sub 1. The y value at x sub 2 minus the y value at x sub 1. In layman's terms, that is really just the change in y over the change in x. The same thing that slope always was. So if there's one takeaway for you today about average rate of change, the word average only implies that it is nonlinear. Rate of change still means slope. Same slope we've always worked with. So I'll do a quick example of what that might look like in your textbook. You're going to have a couple of assignment or problems on an assignment tonight that you'll work on for Monday. And they're pretty basic. Did you have a question, Andy?
Yeah, on the last one.
Mm-hmm.
So it says changing y on the top of it, and 2 it has x on both the bottom and top. How do you do that?
Oh, on the top it was f of x. And remember, f of x is just a fancy way to write y.
Okay.
So those are y's, really. In the book, it's going to be pretty basic when it asks you to do rate of change. It's going to give you the function. So it says f of x is x cubed minus 3x. So that's a function we're looking at. And then it's going to give you the 2 x values that it wants you to find the average rate of change in between. So it's saying x sub 1 is negative 2 and x sub 2 is negative 1. Okay. I'm going to rewrite that formula I gave you. F of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. Well, I already know 2 pieces of that, right? They tell me what the x values are. So I'm going to go ahead and drop those in. That would be negative 1 minus negative 2. I need f of x sub 2 and f of x sub 1. Okay. So f of x sub 2 is really f of negative 1. Just plug negative 1 in for x and see what I get for y. Okay, so that will be negative 1 cubed minus 3 times negative 1. That's negative 1 plus 3, or 2. Okay, so that's just basic computation there. And then I'll do the same thing for f of x sub 2. f of x sub 1. That will be f of negative 2. That will be negative 2 cubed minus 3 times negative 2. That's negative 8 plus 6, so a negative 2. Remember that in the actual formula, you're doing a difference of those values, so you're doing minus negative 2, which really turns into plus. Are we okay with where my numbers came from? Does anybody have any questions that can clarify? Okay. Then you're just doing slope. It's 4 over 1, so the average rate of change there is 4. Please note that if I gave you some other x values, we would expect most often that the average rate of change not be the same because it's nonlinear, different things are happening at different points of the graph, so the average rate of change is going to be changing continuously. Okay, the next thing we're going to talk about is the step function. Okay, this is a genius name for a function that looks like steps. It's amazing. Step functions are graphs that resemble stair steps. The only thing I'll say about that really quickly is if I asked most people to draw stair steps, you would probably draw something like this, but that's not a function because all the vertical pieces do not pass the vertical line test. So when we say that these graphs look like stair steps, they look like floating stair steps. So I imagine it like, if you have a deck, climbing a deck, you don't have that bottom piece right there. Now, one of the common step functions is the greatest integer function. Again, this is something that's on that pink sheet, that 8 basic functions library that you're filling out. So in the function f of x equals column, you can go ahead and write this notation. It looks like basically kind of like absolute value, but there are 2 of them, vertical lines. And also in the book, sometimes it looks like the brackets with 2 lines. Okay, so that would also be the greatest integer function. The greatest integer function just says, like, for whatever's in there, in those grouping symbols that are the greatest integer function, you want to figure out what is the greatest integer that's less than or equal to that value. Okay, what type of numbers are integers? Give me an example of an integer. 2, 3, 4, 5, 1, 0, negative 1, negative 2, negative 3, right? I call those nice numbers. That's not a mathematical term, but aren't you always like, are my answers going to come out nice? And what you really mean is my answer going to be an integer? Am I going to have a decimal or a fraction? Okay, so you can only get outputs that are integers in the greatest integer function. Okay. So we're going to do some examples of evaluating them. I've got them in function notation. Okay. So we'll start with f of 0. Okay. Meaning I'm going to go to that greatest integer function and I'm going to put 0 in for x in the greatest integer function, which is then asking me what's the greatest integer that's less than or equal to 0? 0. It's the greatest integer that's less than or equal to that value, 0. If I put in 0.5, what's the greatest integer that's less than or equal to 0.5? Also 0. Okay, 1 is over 0.5, so it's not part of that. Okay. F of 1, 1. Anytime it's an integer, it's just going to be itself because we have the or equals to part. Okay. And then if I did f of 1.2, 1. It's almost like you're rounding down to the nearest integer. if you think about it like that, round down to the nearest integer, and then we have 2. So notice that our outputs are going to be only these integer answers, 0, 1, 2, 3, 4, and then we're also going to have -1s, -2s, -3s, which results in that sort of floating staircase. So when we graph that, for the greatest integer function, f of 0 is equal to 0, so I do have a point right here at the origin. Okay, and then if I just kind of look at that next one, f of 0.5, if I think about all those decimals in between 0 and 1, 0.2, 0.3, 0.5, 0.7, 0.9, they're all going to round down to 0. So I'm going to be on 0 for a while until I get to 1. Because when I get to 1 for x, I have to then jump up, right, or step up. So now I'd be at 1 there. I need something here to say it stops. I just use an open circle. Okay. That open circle means like that's the boundary, okay, for that particular step. So 1 or 0.9 is going to be 0. 0.99 is also going to be 0. 0.999999 is also going to be 0 until you get to 1. Then you jump up.
I don't know if I missed something, but if you said that we're supposed to round to the nearest whole number, wouldn't the 0.5?
Nope, less than or equal to. It is the number that is less than or equal to x. So you're rounding down to the nearest integer
I got it.
because of the greatest integer function. Okay, and then this one would go until 2, and we'd have to jump up. And we create those steps. Okay. Now, there are other functions. Okay, there's a ceiling function, floor function, they have different names, and sometimes that would mean that like the open and closed circles would be reversed. Okay, it just depends on the definition of the function, but like for Elias, that one, we're talking about the greatest integer function, so you choose the greatest integer less than or equal to. Okay, so on your gold sheet, if you refer to your gold sheet, you do have a set of 6 extra problems. Remember, bold and underlined are required. You should absolutely do them by Monday. It would be ideal that you could do all 6 so you get enough practice. Okay, but at the very least, you're doing the bold and underlined problems. We'll go